Welcome, everyone, and thank you so much for joining us for today's Agribusiness Global Live webinar, Ag Tech Reducing Chemical Crop Protection Inputs. My name is Sarah Webb, and I'm editor of Agribusiness Global and moderator for today's webinar.
And my name is Lauren Milligan. I am the content specialist for the Agribusiness Group, and I will be the co host for today's webinar.
I also want to tell you about what Agribusiness Global has planned for 2026. We have 3 virtual seminars this year, with each focused on a region. The LATAM virtual seminar was held on March 11th, and you can watch it on demand on our website. The ABG Africa virtual seminar will be on July 9th, and the ABG Asia virtual seminar will be on November 19th. Each seminar is 3 hours free of charge and brings together experts so you can learn what's happening in the industry. Also, we have the Agribusiness Global Trade Summit coming up on August 5th and 6th in Las Vegas. This in person event brings together crop protection, biologicals, and fertilizer decision makers. This year will include a special focus for biologicals companies, and programming will include the opportunity to speed pitch to U.S. ag retailers, industry roundtables, and global networking. Plus, participating biologicals companies will also have the chance to win a consultation with Bob Trigell, CEO of Pro Ag Invest. You can scan the QR code to register using the code BIO2026 to receive $200 off registration. We hope to see you there. Lastly, we'd like to thank Rainbow Agro for sponsoring this and this series of webinars. Without their sponsorship, we wouldn't be able to bring you these educational webinars, so thank you, Rainbow Agro. Now, allow me to introduce our speaker. Robert Finger is Professor of Agricultural Economics and Policy at ETH Zurich, Federal Institute of Technology Zurich. His research revolves around agricultural science and economics with the goal of strengthening the resilience and sustainability of agricultural and food systems. Thank you again so much for joining, and let's get started. Robert, please take it away.
Thank you so much for the very kind introduction. Warm welcome. It's a great pleasure and honor to have the opportunity to talk here in that webinar, and I also look forward to the discussion with you. So, the topic I will address is on digital innovations in agriculture and how they actually facilitate, hopefully, the transformation to more sustainable crop protection. But before going into questions of digital technologies and innovations, I would like to start with the fundamental of what we are talking about, namely that crop protection is absolutely crucial, obviously for food security, provision of ecosystem services by the agriculture sector, but also, of course, the economic viability at the level of the farmer and beyond. So crop protection is crucial. And it is becoming more difficult and more relevant, especially because we see, due to climate change, for example, an increase in pest pressure. And this nice title, Protecting Plants, Protecting Lives, was used in an editorial in Nature Plants last week. So I found that very compelling to add that here. Also, and you see a bit the title describing here, to address future agricultural and ecological challenges, plant protection requires integrative efforts and also new technologies. And that's something I will come back to in a minute. And also to clarify early on, pest management, of course, is often involving the use of pesticides. And I won't make a big distinction, but whether they are chemical, synthetic or not. So just there will be a gradient of how tricky the pesticides are done for human health and the environment. We talk about reductions of pesticide use, and we do that for various reasons. First of all, there's an increasing resistance problem, so that's becoming more and more critical for producers worldwide. And of course, pesticides are widely discussed in a society and policy domain because they have negative effects on human health, they have negative effects on the environment and biodiversity, and there are also kind of like evidence for repercussions on agricultural productivity. So overall, we are not talking about removing pesticides, but just reducing it and reducing the risks, especially for the environment and human health. And this is actually nothing that I'm coming up with, but this is just documented in various national action plans and the European level and even at the global level. There have been some commitments made. And in addition, there are public and private incentives to farmers to reduce pesticide use, for example, in agri-environmental schemes, or if there's labeling of pesticide-free or reduced pesticide products. So in the end, it's very clear we need a transition to more sustainable crop protection, and we need that globally. What it means in different places on the world and for different crops, of course, is something very, very different. We try to address that question of the transformation to sustainable crop protection, sustainable pest management in a paper that came out last year in Nature Communications, where we wanted to address expected effects of a global transition to sustainable pest management. Um, we don't know what would happen in the case that we change pest management practices fundamentally. So we used an approach where we kind of surveyed experts from academia, but also from industry, globally in 6 different languages, really representing all parts of the world, and really asked about like what would be the expected effects of sustainable pest management in different domains, and you see some of them indicated here in the graph. Um, and first of all, it's very clear that the transition to sustainable pest management is expected to have a lot of positive effects, according to the experts that we surveyed. The benefits are, I would say, foreseeable, highest, or perceived to be highest in the environment and human health domain. And also very clearly there are trade-offs, especially, for example, in the economic domain, but also then when it comes to crop yields. And we also see stark differences across the globe, how severe, how strong the trade-offs are. So not surprisingly, for Europe and North America, for example, the trade-offs are perceived way higher compared to countries where there's lower income levels and also lower pesticide use in the moment. So there's like a big benefit expected from transition to sustainable pest management, and I will say a few more words what we could potentially understand under that umbrella. However, it's also very clear there are trade-offs in yields, economic performance, and with these trade-offs, it's very hard to make the transition sometimes. So we need to address these trade-offs, and that's going to be part of the story I'm talking about. How to make the transition to sustainable crop protection, pest management. I think making a step from, let's say, the benchmark model, whether it exists or not, where there's a heavy reliance on pesticides alone, um, uh, towards lower pesticide production systems is clearly also associated with concepts like integrated pest management, agroecological crop protection, and many others. But it's very clear integrated pest management gives us the tools and growers the tools to reduce the reliance on pesticide use quite substantially. However, what we see in a European context, but also beyond, even though IPM is mandatory and is widely used, only some chunks of IPM are used, and IPM is very rarely used at the entire package that would allow to meet these ambitious pesticide risk reduction goals, for example, in Europe. And why are farmers not making use of the entire package? Well, simply because it often doesn't pay. So it's costly. There are trade-offs. I indicated that in terms of yields, but also in terms of costs. And usually there's very little compensation for it. So, for example, there's no labeling when it comes to reduced pesticide use, or there are few examples where this is happening. The other example of growing without pesticides, even is of course organic agriculture, or without chemical synthetic pesticides. There are still pesticides used. That is quite also in the policy focus, especially in Europe, where there's a big goal of increasing the share of organic agriculture. Here, farmers are not allowed to use chemical synthetic pesticides. However, there are many other restrictions way beyond pesticides, and there's labeling, so there's a price markup. So farmers can benefit from both public and private support, especially in Europe. And then what we see emerging, maybe also particular for Europe, is in between production systems. So in between conventional and organic production, there are many, many varieties of production systems that emerge. I mean, they are there anyway, but that they are really intentionally used, supported, and also labeled out. So One is pesticide-free but non-organic production, so you wouldn't use chemical synthetic pesticides, but for example, you would still use synthetic fertilizer. So it's not an organic production, but it doesn't use pesticides. And then these can be used to label products. And for example, in Switzerland, 15% of the entire bread, like baking wheat, is produced pesticide-free but non-organic. The right-hand side, you see an example of tomatoes in France that are non-organic but produced without pesticides, and they are labeled like that. Growers would get price markups. And of course, there are also other things. This is an example from a vertical farm in Zurich. And if you go to the shop, they also indicate on their product 0% chemical pesticides, simply because they don't need to use it, but it's also not organic because there's no soil involved, of course. So these are these examples in between. And what is very important for me at that point is that we have these different systems, and in the future we need all of them and not the single one. But if we want to make that transition, we need the huge variety of production systems indicated here, and we also need efficiency, substitution, and redesign. And to get there, and I will come back in a minute to talk about these steps. At the same time, when talking about pesticides and transition to sustainable pest management, it's also very clear that digitalization and AI enabled systems are rapidly transforming agriculture. And what this means is, for example, no, that we have a lot of technologies that basically are allowing georeferencing, location, so pretty much standard GPS and so on. And we have a lot of diagnostic tools. And diagnostic tools, with that I mean sensors, a huge variety of sensors, whether this is on a tractor, on a handheld device, on your smartphone, in space, as a satellite. But we measure tons of things. And this is going to be cheaper, better, and much more broadly applied in the future. So we have a lot of data, and agriculture actually collects so much data already that this is really a valuable asset. However, kind of like to make use of this is actually the next step. So with that information alone, location and having sensors alone, you don't win a lot. But the big steps are made when you go to a next level, where, for example, you use applicative tools. What I understand is a combination of all this information that you collect to basically make better management decisions. For example, in terms of precision agriculture, that you apply pesticides only there where they are needed. In the next step, there is also increasingly an observation that processes, machinery, or entire farming system are automatized or even autonomized, as for example with an autonomous robot. And then on the right-hand side, I want to highlight that most, or like a very big and important part of the digital advances that agriculture is actually seeing in a moment is not something that you can see on the field as a robot, as a tractor, but actually is all the things that happen in the back, whether this is related to facilitated and improved communication, digital twins, and so on. So this is the big setup where we see transformation of agriculture to be more digital globally, as all our societies are undergoing very quickly that development. Agriculture is doing that too. And this also has a lot of opportunities for the plant protection of the future, in my view. The uptake of these technologies is very heterogeneous. I just want to refer here to a couple of presentations, publications by Jonathan McFadden, among many others. So there are some technologies that are widely used in some crops and in some locations, but many others, this is still in its infancy. So there is huge heterogeneity. We can maybe then come back to that in a discussion. But I want to highlight that these digital innovations have the opportunity to support the transition to reduce pesticide use and pesticide risk by actually addressing these 3 points: efficiency, substitution, and redesign. And in the next minutes, I would like to motivate a bit what I mean under these terms, and also give examples how digital technologies can actually facilitate these steps: efficiency, substitution, and redesign. Efficiency is nothing else than doing the same as you do before, produce the same as you do before, but do it with fewer inputs that are required, especially when we talk here about pesticides. So There are lots of examples how digital technologies basically reduce pesticide use and risk without actually changing the production system as such, and without compromising yields. So one example is guidance systems, control traffic farming. We know just like avoiding overlaps, increasing precision, reduces also the use of pesticides by a few percent, super easy to implement, scalable, low cost. So this is going to be, or is the standard in many places on Earth already. So this is a very straightforward technology with rather small reductions of pesticide use. When we talk about efficiency, of course, also variable rate technologies. So for example, in the top right picture that reflects an application of herbicides only there where actually there is the weed pressure sufficiently high. So this is also something where you can save quite a bit of herbicides without compromising yields. And then on the bottom, you see an example of drones. Of course, the application in, for example, in Asia is much wider than, for example, in Europe, and much larger the application. But here in Switzerland, for example, this application in vineyards is very much gaining momentum and also perceived to improve the efficiency of the application of pesticides. So efficiency means we can reduce pesticide use with the support of digital technologies without compromising yields. The next step is to think about how can we actually substitute, where possible, pesticide use with something different that is less harmful in the end for the environment and human health, and can also help to break some resistant problems in between. So, and here the flagship example, of course, are these autonomous weeding robots. This is an example of a spin-off of ETH Catera. In this particular case, the robot is running over the field, identifying weeds, and is applying laser to eliminate the weeds. So this is, of course, completely replacing the use of pesticides, use of herbicides here. However, this is still very expensive, focused on specific crops, highly valuable, usually applied here in vegetable production, and it's not yet widely scalable. There are other examples of substitution that are enabled with digital technologies. I stay in Switzerland with my examples, but this is today the most widely used strategy to control the corn borer in Switzerland, whether in organic or non-organic farming systems. This is based on trichogrammas, so parasitoid wasps, and they are distributed with a drone. So this is a very straightforward service that you can book as a farmer, and then a drone pilot comes, and then the drone is dropping these balls with the trichogramma, and then corn borer control is very straightforward. And this is only enabled because this system with the drone is there and straightforward to use and very cost efficient. So now we talked about efficiency and substitution that would reduce pesticide use or replace pesticide use in specific cases. However, it's basically not addressing the root cause of the problem, so to say. You still have the pest pressure that you need to fight. And this is the next layer that I would suggest, that digital technologies also have the potential to support the redesign of agriculture systems. And what I mean with redesign, I also want to illustrate with examples, but to give you an intuition, redesign means changing the agriculture system in a way that it's less vulnerable to specific pests and diseases, so that you need, in the end, less interventions. And redesign, in that sense, can, for example, mean changing agricultural landscapes. Changing agricultural landscapes has very different facets. So I have 4 examples I want to show you that I find personally very striking. The top left example is a field trial from the ZALF, a research institute in Germany, in the state of Brandenburg, close to Berlin. And basically, this is one field that is chopped into smaller units, into patches. It's called patch crop, where agricultural landscapes are changed, and digital technologies from drones to robots are actually used to to manage the fields, because of course splitting fields into smaller pieces means higher labor demand, higher cost, and breaking up this trade-off to the cost and labor demand, of course, can be facilitated with digital tools. So this is an example where you increase the diversity in the agricultural landscape. With that diversity, you also reduce pest pressure, and you need less interventions. On the bottom, you see a strip cropping example. I think that's also very straightforward for the same reason. Changing agricultural landscapes in that way is very compelling, has also positive effects on the reduction of pest pressure, and well, both very interesting and I think also very scalable in the sense of that we already see some of these approaches emerging. The next two examples I have are maybe a bit more out of scope, but yet there. So I stay in Switzerland with these two examples. So on the top right, you see a wine grower in Switzerland who's actually really changing the vineyards in a way that there are many different things grown in the vineyards. So 1/3 of the wine, the grapes are of the vineyards are taken out and replaced with other things, whether these are trees and forestry systems, but also with cereals in the vineyard. And of course, you can imagine that also this is quite labor intensive. So here also technologies will actually play a vital role of facilitating these production systems. But this is very important because wine is the main pesticide user in European agriculture. And with these systems, you can break actually the pest pressure and reduce the pest pressure and reduce the need for intervention. And on the bottom right, you see an example of a farm close to Switzerland, to Zurich, here that is actually applying mosaic agriculture with various several hundred crops on a hectare, and many of them vegetables, herbs, and so on. But this is a very sophisticated approach in terms of crop rotation planning, but also the operation in the field, where a lot of digital technologies actually only facilitated that this is happening. And actually, this is really something ongoing. I mean, this is a real farm. All of these things are real farms, and quite interesting to see. And also here, they really perceive the reduction of pest pressure as very important, however, enabled by digital technologies. And of course, what we see with these examples, there's a potentially massive reduction of in the use or the necessity to use pesticides here. But of course, many of these things come with costs, are labor intensive, are difficult to scale. And here, digital technologies are really very important to actually to break these trade-offs, and could be a facilitator to change agricultural landscapes of the future. When we talk about redesigning agriculture, I'm not advocating it, but of course, that's also an opportunity that comes from digital tools, that a controlled environment agriculture is there, that is not applicable widely, but for specific things that may make sense to take production indoor. That's also a picture from close to Zurich. So this is also a spin-off of ETH. That produces mainly herbs for the Swiss market in a vertical farm here. And of course, this also has a potential to massively reduce or replace pesticide use. However, clearly has limits to scale. So, for example, the economic viability is limited, energy demand is high, and so. But there are then two things I want to highlight that don't really fit on the field, and you cannot see where I feel digital innovations are really a game changer in terms of all stages of transition that I talked about: efficiency, substitution, redesign. When we talk about, for example, sharing knowledge in new ways, kind of like really fundamentally changing the way extension and advisory service can work, and also the networks that can be created. And this is something you see that here also the headline I have here from that website of Digital AgriHub, scaling digital extension advisory services. So this is really something super important and super powerful, and can be especially viable when you can use these opportunities just to have easy to use and cheap devices such as smartphones. So that's something I think highly underestimated, the power of the better exchange of knowledge and the better provision of information exactly where it's needed. This can be a game changer for crop protection of the future, or it already now is very important, to be honest. And then there are other examples I now picked here. The twins is a very nice example also to kind of like model systems, taking a physical system in a digital sphere and being able to forecast, model, and also test a bit the interventions that you would do before actually the pest arises. So in the end, anticipating problems and making giving farmers an opportunity to anticipate issues and address them before actually the problems arise, and with that also reduce the necessity to make an intervention, whether chemical or not, in the end. This also can be very, very powerful, very much also related to the point I listed earlier. So this is key. There's a great potential here. Now, I talked about different digital technologies, and I would like to kind of like clarify, of course, there's no silver bullet. So none of these technologies is going to be the game changer in every farming system and alone. So definitely not. But there are various pathways how digital innovations can really contribute to pesticide risk reductions and still having a very successful crop protection, which is the main goal, of course, and likely having also economic viability. So I would like to use this structure here to classify technologies. So you see on the top the potential to reduce pesticide use and risk per hectare. So it could be low or high. And then the potential to be scaled, for example, based on the economic performance, the cost, but also regulatory hurdles that actually kick in for some of these technologies. So clearly, if you have low, so scalability low and reduction potential low, it's not a viable pathway. So we can forget about that group. However, there are other technologies like controlled traffic farming, variable rate technologies that actually have a low potential to reduce pesticide use, but low doesn't mean nothing. So there is an important reduction possible. However, they can be scaled very highly. So that's why they are super important and super promising, even though they only reduce pesticide use by a few percent. On the other hand, we have technologies that really have the potential to replace pesticide use in a but totally or largely, like in the systems that are depicted here with breeding robots, controlled environment agriculture, and so on. However, they cannot be scaled. And the scaling potential, of course, that differs a bit across the globe. So currently, for example, unmanned aerial vehicles are still highly regulated in European agriculture, and others they are not. So that's why also it's very context specific how you rank that. And then, of course, there are these things that might in the future be scalable and have the high potential. And in my view, that connects to this information sharing, to the change of agricultural landscapes in the future. So he is really like a very important element where we have likely really a high potential to be scaled and high pesticide reductions being possible. So that's a bit the overview. But of course, I want to come back to that initial idea. So all of these technologies can support efficiency, substitution, redesign, and with that also contribute to make IPM more widely used and like have a deeper IPM use to support also these systems with not only fewer but also without pesticide use, like pesticide-free or organic production systems. And of course, there are many obstacles that farmers have when they are looking to adopt these systems I just shown, but also adopt the technologies we just discussed. So if you have at the very center the decision by a grower to adopt a specific technology, a specific production system, sustainable crop protection as such, there are many kind of like factors influencing that decision. And this is a very kind of like schematic sketch, of course, of all these factors, but I just want to highlight there are technical and economic properties of the alternatives or technologies we talk about. There's a market environment that matters, a policy environment, and there are also very important farmer-specific behavioral factors that matter. And all of these actually can facilitate or hinder the adoption. And clearly, I just want to list a few things from that, and don't maybe you go in a discussion later on in more details here, but of course, it's very clear to specify and and observe that these digital innovations have high economic opportunities, but very often, and not always, but very often, they still are a bit too small, these economic opportunities, to really justify big investments. That's also due to the fact that pesticides, as they are very cheap and efficient. And of course, this may change, especially if you talk about resistance problems. Then often these digital innovations are knowledge intensive, but some are not, like guidance systems or using your smartphone may also not be extremely knowledge intensive. But of course, some technologies really not only require additional money, but also try additional knowledge, and that's important to provide that. And side benefits are often very crucial for the adoption. So maybe labor demand is sometimes the bigger adoption facilitator than the reduction of pesticides, as for example, for an autonomous robot. And then big investments, of course, also imply, well, the comparison between long run benefits and short term costs. So this is always a difficult decision for the farmers, but also some risks. And one key risk I feel is important to highlight when we talk about digital innovations is the technology risk. So the developments are so fast that it's very hard to basically make a right investment decision. So when we talk about these robots, I've just shown the reading robots. Every year there's a new batch of substantially better reading robots on the market. So making it attractive to actually buy it in this very year is very hard, because I anticipate that a much better version is on the market next year. So in that sense, this fast development can also block to some extent adoption and investments. But of course, that's also due to uncertain market environments. We have a lot of uncertainty in the agriculture markets, in the output markets in the moment, and that is not supporting investment. And of course, the acceptance of technologies along all gradients from farmers to consumers is an important question as well. And there are policy barriers sometimes, especially when it comes to regulation. So again, very much depending on the part of the world you're living in, but sometimes the use of autonomous machinery, drones, and so on is also regulated to an extent that it's not supporting the use of these digital innovations. When we talk about digital innovations in agriculture, there are also further risks and challenges that maybe go sometimes beyond the level of the single farm, but are important to highlight. Well, first of all, there's a risk of what we call digital divide, so that some part of the farmer population is benefiting from digital technologies. The others are not then able to make use of these technologies, for example, due to limited economic or educational opportunities. And then the use of technologies and the potential benefits are unequally distributed. There's, of course, also discussions in the literature and in policy society, how digital transformation of agriculture, also in the context of crop protection, is actually changing power concentrations and what that means for the agriculture sector. We also had a paper led by Tobias Dahlhaus, where we argue that digital and autonomous not per se is better for the environment, even though we often assume that. That depends a lot on the underlying goal functions. And then the shift to these new technologies brings also new risks and challenges. For example, new systemic risks due to, for example, algorithmic biases, network vulnerabilities. So even though you wipe out some of your production risks, you are more exposed to risks that come from networks breaking down, hacking, and so on. So that's new risks that enter and are important for the decision-making context. But of course, there are also these questions of responsibility, accountability. So the standard example is like when there's an application of a pesticide on the wrong place, or the wrong pesticide is used on the wrong place, like who's accountable? Is it then, if it is an autonomous process, is it like the software provider, the hardware provider, the farmer? Of course, these things matter then also and need to be clarified in order to make adoption attractive. And then, of course, big questions around data ownership and management. But I think for many of these things, solutions are also there, potentially. So the question is also how to support digital innovations to reduce pesticide use and risk. So I said there are big opportunities, and maybe there are a lot of hurdles that hold back farmers of adopting specific technologies. Um, and in this interface, of course, the intervention of policy might be important. So first of all, digital innovations are as such no panacea for sustainable crop protection and no policy purpose on its own, but there is a potential, and this potential beneficial effect can be exploited. And then the first observation is, of course, that whenever you make pesticide use less attractive, that of course supports also the innovations in pesticide use reduction and technologies to become more attractive. So, for example, if you would put a tax on pesticides, then the adoption of precision farming equipment may go up. But what it definitely needs is an enabling environment and incentives to develop and apply the most cost-efficient strategies in crop protection, whether these are digital or not. That is very case specific. But what it needs and is often lacking is the appropriate infrastructure, appropriate legislation, education. There are economic instruments that can support that transition. What we also see is important is to go beyond single farms and single applications. So whenever you try to support something on one farm alone, often in Europe and other contexts, the farms are too small. So going beyond the single farm can be very important, and the intervention of the government can also point in the right direction. And we also see that pushing for the redesign, this kind of like uh, change in agricultural landscapes is important in addition to efficiency and substitution. And of course, focusing on beyond pesticides. So if digital technologies would only be used in the crop protection context, but probably then you miss some important opportunities, and combining it with other applications can make it cost efficient. Whether these are other inputs like fertilizer use or also other elements. For example, there was a very interesting paper that suggested to use the information collected by a reading robot also in result-based payment schemes, that farmers get compensated if they have specific species on their field that are detected with that. So with that, I would like to come to the conclusions. So I started that a pesticide risk reduction is needed. However, we also need to maintain yields. We need to maintain economic performance. And this needs, in the end, probably a diversity of solutions, diversity of production systems, and a push along that efficiency substitution redesign gradient. So it's not one is better than the other, but we need all of three of them. Um, Digital innovations are no panacea, but they can facilitate these developments. And however, among these technologies, pesticide risk reduction potential and scalability is very context specific. And we currently see that the lack of economic viability and other hurdles holds back some of these innovations to be applied at large scale, especially then probably those that have the highest potential to reduce the reliance on pesticides or change that reliance. We need governance. We need public policies. We also need private companies and private policies here to untap these benefits that are there. And I said that in the beginning, in the end of the last slide, we need focus beyond pesticides is also important. And of course, we also need not only a change in pest management practices, but we need change in the entire agriculture and food systems in order to become more sustainable and fit for future conditions. And this requires not only crop protection to change, but really an agriculture and food system transformation. So with that, thank you very much for your attention.
Thank you so much, Robert, for that presentation and for all your insights. I'm sure it'll be so helpful for our audience members. And we do have about 20 minutes left of this session for a Q&A portion. I see that we have a couple questions trickling in already, but just as a reminder, there's a Q&A box at the bottom of your Zoom panel. Feel free to go ahead and type any questions you have for Robert in that box, and we will try to get to them. Any questions that we don't get to, we will be posting a blog in about 2 weeks' time, and Robert will be able to answer your questions in written format from there. So with that, I'm going to reintroduce our Lauren Milligan, our content specialist, and she is going to be running the Q&A session.
Thanks, Sarah, and thank you, Robert, for your time and for that presentation. That was full of some great information for our audience. As Sarah said, we do have a few questions in the Q&A box right now that I'll go ahead and get started with. Robert, our first question reads, what about the drift and cross-contamination of pesticides in the case of mosaic-shaped production systems? And I know we touched on this a bit during your
Yeah.
presentation.
Thank you very much. I'm just scrolling to the slide where I shared these systems here. No, that's a very valid point. So I think that's a difficult one to refer to that mosaic system that I've shown on the bottom right. So they don't use any pesticides. So that's an organic farm. Well, also the argument is that the mosaic structure as such is allowing them to reduce the pest pressure. So that's that. But clearly in the production systems, as for example shown on the top left, so that's clearly an issue that if you go with the wrong pesticide, that in the wrong field where it's not needed, not allowed, for example, or would harm the production, you clearly have an issue. But this is exactly where I feel these trade-offs where maybe then alternative technologies like smaller scale robots, for example, a drone that applies very precisely pesticides where they're needed, where this could be an kind of like example where you can break these trade-offs that are usually there. But I clearly see the point that when you go back to smaller structures, I mean, to understand the process, agriculture systems have started very fragmented and small scale, and then it developed for very good reasons into larger units, for example, because it's more cost efficient uh, and labor saving and allows the use of specific technologies. Now we try to go a bit back in small steps without actually compromising what we actually gained there. And I think that kind of like making that step back into smaller scale, more diverse agricultural landscapes could be facilitated with technologies that are more precise in the end, right? And actually can support farmers in making the decision where to do what. And that's where I feel there's an opportunity. But yeah, thank you.
Awesome. Thank you so much. We have another question, a couple more in our Q&A box right now. The second question we have for you, Robert, reads, how could chemical crop protection inputs be reduced while maintaining crop productivity, farmer income, and environmental sustainability in underdeveloping countries like Ethiopia because the adoption rate is so much lower?
Yeah, thank you very much. Now that's a very important question, and you have seen that many of my examples are linked to European agriculture, so that's also where my work is actually located. But I clearly see the important point of increasing or kind of like transforming crop protection everywhere globally, because to meet the goals that we have, the SDGs and many others, it's undoubtedly not only a North American or European transformation required, but globally. And I think I would like to go back to one of the slides I had at the beginning. This one with the expected effects of a global transformation of agriculture pest management. So when we surveyed the experts, which we are not for Africa, for example, then those experts that actually identified themselves as having the expertise there, um, they highlighted that there's a large kind of like opportunity of transforming crop protection with a lot of win-wins in the context of many African regions. And I think that's really an opportunity to well, avoid perhaps some lock-ins that have been made elsewhere, to make use also of the big kind of like advancements that have been made in many of the technologies. So I just also later on referred with the digital technologies that there's not only hardware that matters. So I don't foresee that autonomous robots are in 10 years running over every single field. So that's probably not what's going to happen. But what definitely is taking place already now and can be facilitated scale and actually really tapped on is the use of, for example, information sharing and kind of like really good tools to support farmers in the decision making. And it's really perhaps an opportunity to get it all, in a sense of to save inputs where it's possible, to save yields wherever there is a risk of losing them. And if this comes on the same hand with reductions of harms for the environment and human health, then it's even better. But I think here is really a big opportunity of many of the technologies I talked about, not necessarily only about the hardware, but really also everything around it, because there is a huge potential in my view.
Wonderful. And for our next question from our audience, this one reads, what do you see as the most important research gap in improving pesticide use efficiency among smallholder farms in sub-Saharan Africa, particularly Nigeria? And also, how can emerging researchers contribute evidence that informs both policy and sustainable agriculture practices?
Phew, yeah. No, again, I think one point that I have to really clarify, that I'm not the expert neither for Ethiopia nor Nigeria, but certainly it can tap on what I have said earlier. I also believe, because the question here points to it, that policy is important, that we don't leave farmers alone in the decision-making context of crop protection and the use of digital innovations, but it's really like a kind of like a guidance there when it comes to creating the right infrastructure, the right the enabling environment, that things can happen, and that also connects a lot to education and opportunities where there can and should be a public effort to do that. And in terms of research, I feel there's, of course, a lot of research on transformation of crop protection in terms of integrated pest management worldwide. But I think that interface, how digital technologies can actually facilitate integrated pest management to be scaled further in a way that it's avoiding the trade-offs that are currently underlying a process. For example, avoiding yield reductions, avoiding income reductions, avoiding risk increases for the growers. So this is an interface that is really very important. And in my view, what is also missing from a research side is often this integrated perspective. So we often look at farmers and what farmers should and could do differently. But of course, we forget about all these things that happened before it actually reaches the farm and afterwards. So up and downstream sectors are super important, because if nobody's providing the solutions and technologies that farmers can use to reduce pesticide use, it doesn't happen. And if nobody is buying the products that they produce um, for an appropriate price, then this transformation is also not going to happen. So this is also something I feel is very important to look at the system at large. Yeah.
Wonderful. Thank you, Robert. And just as a reminder to our audience, if you do have a question for Robert, we are taking live questions right now in the Q&A box at the bottom of your screen. And any questions we may not get to within the next 10 minutes or so, we will have Robert answer via a blog post that will be available along with this recording in about 2 weeks' time. With that being said, Robert, I do have a couple more questions for you from our audience. Our next one reads, what is the role of innovative new companies and startups in this transformation? And where do you advise a venture capital firm to invest?
Yeah, thank you very much. The role of innovative and new companies and startups. So, well, first of all, I've shown some examples where I link to spin-offs of ETH that probably is not. I mean, I use it to make advertisement, but it's also because I know these examples. And of course, this is an important element, that there are these kind of like emerging, innovative companies, startups that actually come up with a lot of fantastic ideas. And I think when you start digging into that landscape, it's really cool to see. I mean, how many brilliant ideas are there. And I think the important element is how to bring that to large scale application. And I think there we still have a bit of a gap. We have like lots of good ideas. We have, however, also seen some of the very much hyped kind of like solutions not flying very high like later on. And of course, this is due to the things that I listed earlier, that relates to the economics also of, for example, saving pesticides. But I think there's also a structural um, problem or opportunity to support these companies and ideas. So one part is that bigger companies actually take over these startups and integrate them into their larger business models. So I think all companies that produce and sell pesticides, meanwhile, also have a lot of uh, kind of like things in their portfolio where they actually sell services to farmers and or new technologies. So that's definitely something that was taken up by the larger industry. But I think it's also a big opportunity to not only enable that ideas from a government perspective, from a public policy perspective, not only ensure that ideas are generated and you have a spin-off from a university, for example, but really make sure that there's also a transition so that they are actually also nurtured. But um, it's not an easy one, but an important one because a lot of innovation is happening, and this can many of these ideas can be game changers for agriculture of the future. Yeah.
Absolutely. Thank you, Robert. For our next question, this one reads, we find that with so much generic branding, trying to set up a resistance monitoring management on pesticide use. Um, any best practices you can advise on this subject regarding a generic brand and setting up a resistance monitoring management with pesticide use?
Well, no, good question. I have no best practice advice, unfortunately, but I feel it's a very important question. I haven't maybe touched up on it too much 2 or 3 times during the presentation, but I feel that question of resistance and resistance management is really like a crucial one because this is one of the big pressures that also face agricultural production. And then I think we um, maybe again, it's very context specific, but I have a bit the impression in continents like Europe, it's underestimated what that brings because we have increasing resistance. We don't have an large increase in the toolbox, in the chemical toolbox, so it's very slow bringing new products to the market, and the innovation in terms of new modes of action, so to say, is not super high. So here really is a crucial element that also can support growers making the right decisions. And I think also just sharing one reflection with that reading Robert that is shown here. So of course that could be also in the crops where this is used, like carrots and so on. You have a lot of herbicide applications. So sometimes just bringing in mechanical or laser application can be also good for the reason of just like breaking a bit the resistance issue. So there can be really attractive opportunities to not fully replace pesticides, but also just use new technologies to maybe sometimes kind of like really reduce that burden that comes from the resistance that you may build up. So I feel it's very important, but I have no, unfortunately, practical advice. So I'm learning from you if you reach out with your ideas. So thank you very much.
Yeah, thank you, Robert. And for our next question, where do you think it is the place of pesticide management in terms of efficiency and digitalization in Swiss agriculture?
So where's the place of pesticide management? Um, but I'm unsure whether I fully understand the question, but maybe just also, I think a bit like a background that might be interesting for some of you. So, of course, I said that all countries have these kind of like goals to reduce pesticides, but Switzerland also is facing a different pace than other countries in that development. For example, because there's high societal and political pressure. 2021, there was a vote of the Swiss people whether to ban all chemical synthetic pesticides from Switzerland at large. So this is called like a popular initiative where you have you can propose a change of the constitution, and that proposal was to change the Swiss constitution in a way that there are no chemical synthetic pesticides allowed. It was rejected, but it was only rejected because there were many compromises made. So this was really a very strong push from a societal and political point of view that there are very ambitious pesticide reduction goals, perhaps more ambitious than in other countries, and also policies hold a bit accountable for that, more than in other countries, because there is this kind of like this alternative scenario of banning everything. And I think that pushed quite a bit, to and led to support, financial support of pesticide reduction use. Also, the use of digital technologies was tested in some regions with support, whether this is the game changer for the pesticide use and crop protection question. So there's quite some innovation in that sense. So this is where there is a specific pressure that we see in an environment where also then new solutions are urgently needed and people start actually adopting things. So that's quite interesting to see. However, still, I think it needs reflection on what is the most cost-efficient way. So if you put a lot of subsidies to agriculture to not use pesticides, of course, that changes the pesticide use, but it's a bit the question whether this is the most cost-efficient way. So here Switzerland actually it's a good case study because many things are going on. And of course, as I also try to refer to, there's quite a lot of technology development around, quite a lot of innovation. Universities like ETH Zurich and many others. And I think that's also an environment where when you have the right problems and ask the right questions, also very important solutions are emerging together, of course, always with very talented and smart farmers.
Absolutely. Thank you, Robert. And I've got one more question for you before we wrap up our hour with you, Robert. And that is, how can manufacturers remain competitive as demand shifts toward lower volume but higher precision crop protection products?
Can you repeat, sorry? Uh,
Yes. How can manufacturers remain competitive as demand shifts toward lower volume, higher precision crop protection products?
yeah. So manufacturers of pesticides or like, yeah,
So manufacturers, we're asking how they can remain competitive as the demand shifts toward lower volume but higher
yeah,
precision crop protection products.
yeah, yeah. Okay. No, 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 I get it. Last year we had a presentation here at the University of Zurich next door from the CEO of Syngenta, which is also based in Switzerland, and they said they don't sell volume, they sell service. So um, that's basically the reflection on that. I think they also anticipate when you have reductions in demand, so to say, for pesticides and reductions in volume. They actually have services that they provide to farmers, to growers, in order to kind of like make that reduction in a way that it's not affecting yields and economic viability. So I feel there's quite a market that actually opens for many, including those that currently produce pesticides. I said they all invest heavily in new technology and biological pest control. I haven't talked about that. So there's really like a big market, and I think everybody understands that these market opportunities are there. They're real. They will be important for the future. Maybe allow me one reflection. Of course, there's always a bit of mismatch. So all pesticide producers say, well, they do that anyway, biologicals and all the reduction things. But of course, if you look from a public policy perspective and from the goals, for example, that are indicated at the level of the European Union, reducing pesticide use and risk by 50% until 2030, many of the things that are ongoing are not going on fast enough to actually meet these short-term goals. So this is often where I think everybody is thinking in the same direction, however, with a different timeline in mind. And I think that's often also reflected in these discussions that we have. But overall, I feel large producers will play a role in the future, but also small companies, as we discussed, and perhaps also totally new actors entered it, because if you can provide information to farmers, also other companies actually have that access to farmers. And so it's really interesting and important also to see how this develops for the future. And yeah, I hope we can also provide input to the process and steer it together in a way that it's really beneficial both for agricultural production, farmers, and the environment in the end. Okay.
Absolutely. And thank you so much, Robert, again for answering those questions and for your presentation. Like I said, it was so insightful. Thank you to all of our audience members for joining today. And thank you again to our sponsor, Rainbow Agro, for making webinars like this possible. We hope to see you all soon. Thanks again.
Thank you very much. Bye bye.